And now I'm happy to turn it over to Sarah Comprood. I just took a peek outside. I think it's clear. I'm crossing my fingers that you guys will have some great live shows tonight. So Sarah will be with members of our planetarium team, Tad and Megan, for some telescope views from outside. So keep those questions coming from the audience and take it away, Sarah.
Okay. Welcome everyone back to night 3. We actually do have clear skies out there right now. And so Tad and Megan, two other members of our planetarium staff here at the Bell, are upstairs with 3 of our telescopes actually. So that's great. And it might be the only clear sky we have this week, although Friday's looking a little bit promising. So let's cross our fingers for Friday. We get a second clear night, but let's go ahead and take a look at a star map so we know what we're looking at here. So this is our star map tonight. You can download these from our website. We can go ahead and put the short link the link to our website into the chat. But if you have any questions along the way this evening or comments, please use the Q&A box and we'll get to as many of them as we can. But this star map right here is showing the sky shortly after sunset. We're a little bit further than that now that it's no longer daylight savings. As we look at our star map here, we can see the outer edges. That outer circle of the map is our horizon. And then in the southwest of our map, we see Jupiter and Saturn. Now, those have now dipped below our tree line. And so those are setting now earlier and earlier each evening. However, that means the objects over on the eastern part of our map are rising higher and higher in our sky. So Mars is nice and bright outside right now. It even has like an orangish hue to it. So if you get a chance to look outside your window, either now or anytime later this evening, definitely take a look for that bright Mars kind of passing our southeast. And as the night goes on, it'll be high overhead in the south. But the winter is actually one of my favorite periods of time to go outside and stargaze. Because even though it's getting colder and that means we have to bundle up, that's actually when I think the sky has the most to offer, because we're getting these gorgeous views of our winter constellations. We see here in our star map over on the eastern edge of it, we have Taurus rising. And nearby Taurus, we're going to get Orion coming up earlier and earlier each evening as well. And so as the weather gets colder, the air gets colder and more stable. And then we have these gorgeous deep space objects coming up in our eastern sky as well. And as always, if the outer circle here of our star map is the horizon, the center of our star map is the zenith, that's straight overhead. And so we have a few telescopes upstairs set up. And then as soon as Tad is ready, I'll let him jump in and introduce himself and what telescopes he has upstairs. But if any of you have favorite objects, we can add a few of them to the Q&A box and we'll get to what we can tonight. How about we try to do that for a little bit here? But okay. So how are we doing upstairs on the rooftop, Tad? Okay, I see him there. He gave me the 2 fingers. So he just needs a few more moments here to get us going, it looks like. One of my favorite things in the sky that is rising is in Taurus the Bull. So we look on the eastern edge of our star map here. We see those, the big V here in the east. Those are the horns of Taurus. That bright star right there is Aldebaran, but not too far off of the horns of the bull right here, the Pleiades, M45. That is a gorgeous open star cluster. That's one of my favorite objects to see in the sky. So we'll see if we can get to that tonight as well. But I know Tad's favorite thing is Saturn, and that has set below the horizon here for us, unfortunately. But Mars is a gorgeous view out as well. Oh, I do want to put a plug in before we go. I forgot to mention, in the middle of our sky tonight and in the middle of our star map is the constellation of Pegasus. So if you were tuned in Monday night, or if you heard earlier, we're doing a challenge here. The Citizen Science Project Globe at Night is measuring how dark our skies are from different locations. And so we're going to strive to get 500 observations in this week, all from Minnesota. And that is of the constellation right here in the center of our star map. It's marked by the fall square And then it has the head of the horse Pegasus arcing down here kind of towards the south. And then it has the front legs of the horse right here kind of towards the middle of our map to the zenith. So that is the constellation of Pegasus. Definitely take a look at Globe at Night and try to find this constellation here. It is just that front half of the horse, and it is kind of upside down here from the northern hemisphere. Okay. Is it okay? The question came in already. Is it okay to do citizen science globe star measure later tonight, or does it have to occur 2 hours after sunset only? Well, they do encourage you to do 2 hours after sunset, but one of the things that you would be marking off on your record or on your measurements is when you went out. It would be the time and the date, and then, of course, the weather thing. So right now we are nearing the new moon, and that's the perfect time to do it. So the moon isn't producing any of its, or isn't reflecting back any light to help us get a true measurement of how dark those skies actually are. So you don't have to, I don't think you have to wait for only 2 hours after sunset, but it will ask you what time you're out there and doing it. Absolutely.
All
Okay,
right,
how are we doing, Tad?
Yeah, we're good. Megan is acting as a spotlight. I'll try to get an image of this later. She's standing on a chair trying to light me up here. So thank you, Megan. Megan Weddle, that's right, your last name, right? Weddle? Sure. Is one of our students, one of our student staff. Megan, what are you studying? Earth Sciences? Yep. Earth Sciences, here at the U. One of those rock lickers, as we like to call them. She says absolutely. So, all right. I'm just going to get going here. I'm going to share a screen, hopefully. All right. So it is very blurry. It is very blurry. But we are looking at Mars here. And we got a couple things going. It's been really hard to focus tonight. I'm not sure if that's something with the telescopes. There's a lot of moisture in the atmosphere as well.
Well, it did just snow, and so yeah.
Yes, thank you for reminding everyone of that, Sarah.
My pleasure.
But yeah, Sarah, I'm gonna actually, if you can take it away with Mars, I'm gonna try to make sure our other scope is going right along.
Okay. So Mars here is actually pretty cool because each night is different for the conditions for stargazing. And one of the fun things that when we first pointed telescopes at Mars, and I'm forgetting his name now, Sally or Tad, if you remember what his name is, but he looked at Mars and he got a little bit more clarity than we're getting at the moment through our camera. But he saw these little black squiggle lines going across it, and they looked like canals. Now, Mars's surface is kind of this dusty reddish color because of the iron on the surface has rusted. So it essentially is just covered in rust. But at different parts, there are different kind of colored rocks. Some of them are a little bit darker based on the mineral content. Some areas had volcanoes. Schiaparelli is one of them. Yes, thank you, Ron. See, he's the one who saw those canals or canales. And so what he saw, not knowing, is he saw these lines going across and not knowing what they are. They reminded him of agricultural canals to divert water. And so some of the very first observations we had of the surface of Mars here was actually something we thought there could be life on Mars because we didn't know what we were looking at, but it looked very similar to things we had here on Earth. Now, the human brain is great at making comparisons, but sometimes our comparisons are wrong. Like there's actually no agricultural canals on Mars. We now know that because we sent rovers and orbiters to Mars and have found it. We landed things. There are no agricultural fields there. But it did kind of spark that mystery of Mars and are there Martians out there? And so it's kind of a fun thing to think about how far down can our human brains think of cool, interesting things. Does it venture down into sci-fi, which one day becomes real? Because we find things like black holes, or one day we might find a bacteria or something on Mars, and technically that would be a Martian. And so we see different views here of Mars, and it is fun to watch from night to night. Are there any questions about Mars while we're here taking a look at it? Okay. And one of the things that we have in common with Mars is that we both have seasons. So we here on Earth are entering our winter season in the Northern Hemisphere, where Mars had its first day of winter in the Northern Hemisphere back in September. So sometimes when we look out at Mars through our scopes, we've actually been able to catch a glimpse of the southern ice cap on Mars even. Because Mars, like we were talking about a little bit ago, has a lot of comparisons to Earth. It has volcanoes, it has ice caps. There is this process called sublimation, where the carbon dioxide in the atmosphere will either, when it gets too cold, it'll freeze right into ice, but then it warms up even so slightly, that ice will go right back into the gas form, and it actually makes these trails, these little black squiggles going down the sides of the craters, and it looks like water could be flowing, but really what it is that ice is going from solid form into gas form, and some of the sand and dirt that was sitting on top of it kind of slide down those crater walls. But Megan, being from the geology side of things, can probably fill in if she wants to or is able to. I know she's writing scopes right now. Talk more about kind of the geological features that we find here on Earth and on Mars. We have a few questions coming in. Nora would like to know the origin of the name Mars. That is a great question because our planets get their names from Greek and Roman gods and goddesses. So when we look up at the sky on our star map, we have Jupiter, which is the Roman name for the king of all the gods, Zeus. And it's fitting because it's the biggest planet we have. Mars, because it has this reddish glow, reddish hue to it in our sky, was named after the Greek god Ares, god of war. And so all of our planets get their names from Greek and Roman gods and goddesses. So it's kind of a fun theme that we're sticking to here as we find planets out there. Greg is asking, does Mars have oxygen to cause the rust reaction? There is a little bit of oxygen on Mars, yes. Now, Mars's atmosphere is very, very, very thin. It's enough that it's there, that if we were to send something to Mars and not give it a parachute to land on the surface, that atmosphere would essentially burn it up, much like a meteorite coming into the Earth's atmosphere. However, that atmosphere is not thick enough that parachute, for instance, Curiosity, when it was parachuting down to the surface of Mars, the parachute only slowed it down to about 200 miles per hour. And so the atmosphere is very thin and mostly made out of carbon dioxide, but it does have just a touch of oxygen in it. And then we have found pockets of water, mostly frozen, very, very salty as well. But there is enough oxygen there that it has rusted kind of that surface of Mars, giving it its reddish color here. But we found that if we dig underneath that surface rock, that our rovers and our landers over the past years have found the rock underneath is still kind of gray. It hasn't fully rusted yet. So yes, there's just a little bit of oxygen on Mars. Nothing for us to breathe, though. Okay, so we have, what can you talk about size, surface, distance from the Earth? Is it solid? So Mars is, like I said, very similar to Earth. It is a rocky planet, so it is solid. However, it is much smaller than the Earth. It's only about half of the size of Earth. So it is much, much smaller. And distance from the Earth, it's about 1.5 times the distance from the sun as we are. So a trip to Mars takes a robot about 7 months or so. For humans, because we probably can't go as fast as we can launch rockets with inanimate objects in it, would probably take us closer to 9 months to get there, a mission with humans on board. So that's kind of how far it is. And as we're looking at, Jerry's asking, as we look at Mars right now, where is the northern pole and southern pole in this image? Now, I'm not quite sure what the camera orientation is upstairs at the moment, capturing this. So I'm going to maybe leave that one to Tad because I can't quite tell from this image. But if you see a little white spot kind of on one of the edges, either up at the 12 o'clock area or maybe down at the 6 o'clock area, if you imagine like the face of a clock, that's roughly where it should be in the sky because its tilt is not that different from Earth's.
All right, Sarah. So this is getting a little tech specs here. We're seeing this through a Canon Rebel T6, which you can see up in the top here. And the telescope is a Celestron Schmidt-Cassegrain. So it's at prime focus. So this should just be flipped left, right. If I'm remembering this correctly, it's always, someone's going to double check me on this, I'm sure. So I believe north is up and east is left. Does that sound right? I'm gonna wait. It sounds like we have some MAS members who are I'm sure gonna be very quick to correct me if I got that wrong. All right, so that's roughly what that hopefully gets you in the realm of where things are. We're trying to get M15 in our other telescope. It's gonna be another minute though.
Okay.
So if you just bear with us, we will try to get that for everyone to enjoy.
Okay. Yeah. Tad and Megan upstairs, between the two of them, they're juggling about 3 scopes and 3 different cameras up there. And it's a little bit cold, so it's kind of hard sometimes to control things with very cold fingers and gloves. There is a suggestion on camera settings, Tad, if you want to take a look at the Q&A there. But I know you're working on M15, which is a really, I was looking at it earlier this evening as we were setting up scopes. It's another one of those funky named things. It's a globular cluster, but it was gorgeous. So yeah. Now, how many of you are like early morning birds? So right now it's getting fairly late, and I'm a night owl, and so I stay up to watch Mars here. Jupiter and Saturn are pretty up shortly after sunset. But if any of you are early birds, rising in the east just before sunset, we actually get a 4th planet in our sky, Venus. Now, Venus is gorgeous, and it actually orbits the sun faster than we do. And so right now it's up in the early morning sky, but I'm going to wait a few more months till it comes back in the evening. But one of the cool things to do about looking at Venus in the sky is that it goes through phases much like our moon does. And so I'm hoping once it comes back into the evening sky, we'll be able to use our equipment here to start capturing the phases of Venus. And so there's a 4th planet in the sky tonight if you are an early bird, if you want to wait up that early for it. It's about 4 a.m., I believe. Okay. Now, another cool thing that's coming up here is I'm going to share my screen, Tad. We're going to go back to our star map. And if we take a look where Mars is tonight, it's not too far away from the Great Square of Pegasus, that fall constellation that is the globe at night focus. Mars is down here in Pisces, so it's not too far away in our sky. Now, Pisces here is a very faint constellation. Its stars aren't very bright, and it's actually kind of hard to see. But if you use the placement of Mars, which is fairly obvious in the sky because it's going to be nice and bright and kind of orangish color, and that square of Pegasus, you can take a look for this circlet, this head of the western fish. If you imagine that being a fish, and then it kind of being tied with a cord or a ribbon, this nice big V, we have kind of the eastern fish here in this other upper triangle. Well, if we kind of keep our gaze going east, we get back to the Pleiades, which is in Taurus the Bull. We also have the Hyades, which are coming up in the winter sky as well. So those are some of the other great things that are visible in the winter sky. And these 2 objects, the Hyades and the Pleiades, these are naked eye objects. So you don't need a telescope, you don't need binoculars. If you happen to have either of those, you can see them even better. And in some cases, it's best to view these things naked eye versus sometimes telescopes get too close in or like too small of a field of view, and you miss a lot of what's going on. Oh, great question there. Marty's asking what time is this star map showing? So the star map we have on screen is just a little bit after sunset. So we're about an hour past this by now. So right here on screen, it's going to be about 7:30, 8 o'clock-ish. So things have shifted. Jupiter and Saturn here in our star map have set. So this is not an interactive star map. But other things are rising in the east as we go through the night. But this is shortly after sunset. Yep. Okay. And so what Tad said he is putting up is M15. So back to that globe at night constellation Pegasus here, that fall square going up to the head. The head of Pegasus is Enif. It's a fairly bright star. And it's actually one of the brighter ones in Pegasus here. It's the brightest one in Pegasus. And then M15 is just off to the head of Pegasus. And I see Tad's face popping in. Are you guys ready for us?
I think so. We've got M15. Going to be from the tablet here, so it's going to take just a second to bring this up. And I'll kick your share off.
Go for it.
So you all got to see our somewhat cluttered tablet desktop there. And then you can see this is our camera. It's this is our application here. It's currently live stacking. So for most things you see, they are not a single image. That image of Mars was very, very bright. We can do that for planets. We can take very short exposures and we can just show that single image. But for most objects in the sky, they're very faint. So we take a ton of images and we stack them on top of each other. Quite literally in the way it works, they each get overlaid. And so the camera here is taking 5-second exposures at bin 2 for those who are interested in that. And it is showing us several 100,000 stars in Messier 15, this beautiful globular cluster. These are some of my favorite objects in the entire sky. Sarah, I think we share that. That love of globulars.
Yes.
And I'm sorry, I've missed most of what you said. So feel free to stop me if I'm just repeating stuff here. But these are actually in orbit around our galaxy. So M15 is going to be around 20,000 light years away, more or less. We'll get an exact number later if we need to. And what's really cool is globulars are incredibly old. They are as old as or older than the galaxies that they orbit around. So the stars in this globular will date back 12, 13 billion years. We can tell that because when we look here, we have these very chemically simple stars. They're mostly just hydrogen and helium. They don't have any of those higher elements, those heavier elements that form when stars die. So these stars, because they don't have that, they necessarily were born at a time when all that other stuff wasn't around. Hence this incredibly old age. And they're pretty small stars, or overall are average size, so they can last billions and billions of years. So they're going to be similar to our sun, or even a little smaller to really live this long.
Yeah.
Again, Sarah, take it away.
One of the things that I love about globular clusters is, one, it's I think mind-boggling how many stars can be packed into this cluster here. The name is kind of sometimes a tongue-tying name, globular cluster, and yes, it's not a pretty sounding name at all. But the objects themselves are gorgeous. And they're different from other types of clusters, like an open cluster. And like Tad said, they're orbiting the galaxies that they're in. So if you imagine the Milky Way galaxy, we can see it stretched across our sky, kind of this time of year, kind of east to west-ish. If you think of the Milky Way galaxy as this nice flat plane, kind of like a big, huge fried egg, if you will. So if you look at the edge of it, it looks like a big, flat egg white, and then the center is the yolk that kind of has that bubble in the middle. These kind of hang out outside, kind of in the halo around our galaxies. So they're not actually in the disk of the galaxy or that egg yolk part of the fried egg, but they're kind of orbiting out around in the halo of our galaxy. So this is maybe a question for MIFA, but the idea that some of these stars are older than the galaxies, so then it becomes the question, what was around first? Were these stars in these globular clusters around first, and then the galaxy formed around them, or did the galaxy and the star cluster form at the same time? And it's kind of that chicken and the egg example, but in this case, we're talking about stars and galaxies. So I think it's a really kind of a fun trick of the mind and try to time scale puzzle to figure out of how old are these things compared to the objects around them or the galaxies that they're nearest are in. And they're actually a bunch all over our sky. And so M15 here is in Pegasus. But there's some other ones out there in the sky. So if you have a love of globular clusters like Tad and I, they're kind of these little mini treasure troves, these little jewel boxes all over the sky. So they're quite fun to look at. Okay. So we have a question here. What holds a globular cluster together? Why don't they get drawn into the galaxy they're orbiting? Now, this is kind of a question that relates back to what came first, the cluster or the galaxy. The cluster itself is being kind of held together kind of by its own gravity, if you will. Now, the stars aren't going to kind of collide and kind of merge. They're all fairly stable, but they're still bound together gravitationally. And so that's what's kind of holding them there. But each star will have its own motion. These things are so far away, and these actually take up quite a lot of space in outer space that we're not going to notice individual stars' motion on a human time scale here unless we have very, very precise measurements. But why don't they get drawn into the galaxy they're orbiting? You know what? I don't know that I have a fully satisfying answer even for myself on that, other than they're far enough away where their orbit is stable. Now, for instance, the moon is a fairly stable orbit around Earth. So the moon isn't crashing into the Earth. With that said, the moon is slowly drifting away from the Earth, so it's maybe not the greatest example. But stable orbits do exist where they don't have to get pulled in to a larger body. Okay, Ken is asking, is this really a cluster, or does it appear to be a cluster based on our perspective? Great question. This is truly a cluster. Sometimes we see two stars that look like they're right next to each other, or multiple stars that look like they're right next to each other. But when we do a measurement of how far away they are to really calculate how far away they are, they could be light years apart. One just closer to us and the other one in the same eye line just further away. In these cases with globular clusters, we have measured enough of them to know that they are all together and they all are all roughly the same distance from the Earth. Yes. Great question, though. Okay. Are you ready for us, Tad? I can see a shadow in the back there.
Sorry, not quite. I'm trying to get an open cluster into view, and I'm having a little bit of trouble doing that. So if you give me maybe 5 minutes, I think I'm on it. I think my telescope's gone right to it. I'm just going to do a little bit of work to get it actually into view. But hopefully we should have an open cluster, one of my new favorites, coming into view.
Okay. Okay, so as Tad's working on that, and we will get into what's the difference between this globular cluster we're looking at here and an open cluster. It looks like Robert's asking, what software and hardware are we using to do the live stacking? So what we're looking at right now on the screen is the globular cluster, and we are using the ZWO ASI Air Pro. And so that's a little tiny red box. It's essentially a Raspberry Pi computer that is talking to our tablet. Those two things are also talking to a ZWO ASI 183 millimeter camera. Now it's a monochrome camera, meaning it's only taking pictures in black and white. We do have colored cameras upstairs as well. We saw that with Mars. Now the reason why sometimes we take colored images versus these black and white images is the cameras and the detectors for black and white, sometimes like this, they're gorgeous, and we want to use all the pixels in the camera to really tell the depth and the brightness of the entire object, especially with deep space objects that are really far away, that it's very faint light getting to our eyes. So we really want to stack as much light on top of each other as we can. And so we just want to use all the light as black or white to do that. Now, Tad mentioned that we were using a DSLR upstairs as well for the colored image of Mars. Now, because Mars is a lot closer, we can pick up that color because each pixel will have its own color assignment, whether it's looking just for the green light or the blue light or the red light. And then in many times on a chip or in a camera like this for astrophotography, your green chips will outnumber your red or your blue chips. And so they each have an assigned color to detect. And so when we're looking at things that are very faint and very far away, we want to use all of that light. So use black and white. But at things like Mars, where we know there's enough light coming from it, we can really start detecting color individually on those three different primary colors of light to mix it together, give us that very vibrant image. So yes, we have a few different cameras going on upstairs there. Okay. So does anybody have a favorite object in the night sky they try to find, or maybe an object they want to find they've had some trouble finding? So I want to know what you guys have tried looking outside, because here in the cities, if you heard Mike Shaw's talk, there's different levels of darkness around the state. And here in the cities, we're actually pretty bright skies because we have all the city lights going on. But there's still great things you can see here. For instance, the globular cluster. A lot of these can be just binocular objects. One of them said the double cluster in Perseus. Yes. So the double cluster in Perseus is actually, I'm going to switch us back to our star map here so we can see where that object is.
And Sarah, once you're good, I think I can. Why don't you go over the star map, and then I'm going to try to bring up a open cluster here.
Which open cluster are you going to look at?
Oh, we're going to wait for that. Just wait.
Oh, okay. He's going to surprise us.
All right. And Megan's gone back in. I should say, for those concerned about Megan's welfare, she's gone back inside to warm up a little bit. So don't worry.
It's cold outside, but it's not that cold. I've been outside with telescopes in much colder weather.
There's a lot of frost covering. I'm just going to say,
Yes.
I was a little worried actually about capturing anything because the telescopes are covered in frost right now. It may not be very cold, but it's very humid.
Yes. Okay. So if we're looking at our star map again here, the double cluster in Perseus. So we'll use Pegasus as our guiding constellation again tonight. Now, if we go where the hind legs of Pegasus you would think would be, but it's not. It's actually the constellation of Andromeda. You can imagine arms and the torso and then the legs of Andromeda there. Perseus is just over here to the northeast of Andromeda. And you can imagine his head, here's kind of this pointy thing, and then his arms kind of curling out like that. The double cluster is just above Perseus's head. And it's actually just below Queen Cassiopeia here, this W shape in our sky, kind of middle of our map. So this W of Queen Cassiopeia is visible all year long. And so if you wanted to use the central star as a guiding point to go down the length here to this one of the points of the M or the W, and keep going towards Perseus, then you'll hit the double cluster. So that's a tip on how to find it. And that was actually one that we tried to look at through our camera, I think in our October star party. And our telescopes actually had a smaller field of view. So we were only able to get one of these two double clusters here. So this is actually a great binocular object, or even under really dark skies, a naked eye object, because telescopes can sometimes get too focused in and you don't actually get to see both of them. So that's an example of how telescopes might get in your way. Okay, you're going to surprise us, Tad?
All right. Now, I do hope this is coming into view. It's a little dark on my screen, so hopefully this is coming into view for y'all. Feel free to put a question that is saying, no, it's not, if it's not. What we're looking at here is known as C50, I'm sorry to get that wrong. Caroline's Rose Cluster, or NGC 7789. It's one of many clusters, many objects discovered by Caroline Herschel, going over a little 200 years now. And it gets named the Rose Cluster because if you start to pick out what you're seeing here, the stars in this cluster, which are all right around should be the center right of your field of view. I'm not sure if my mouse is visible. They sort of look like rose petals. The different star groupings together. In particular, the upper right, I can sort of pick out one, and sort of looking to the left, I can see these shapes here. It's a fairly old cluster. It's estimated to be about 1.5 billion years old. One way we can tell that age is we have a lot of red stars. You can start to see some of that color there, in fact. So these stars are getting nearer to the end of their lives, so they're changing color. They're becoming red giants. And yeah, it's not a very well-studied cluster overall. There's really just sort of basic info about it. It's probably about 6,000 light years away. And there's somewhere between 500 and 1,000 stars altogether in the cluster. But it's located near Cassiopeia, in fact. It's right up near the zenith, the top of the sky. And it's honestly, I just think it's a really beautiful object. I've quite enjoyed, I got some images of this before, and I'm really enjoying seeing it again. For For those wondering what's going on tech-wise, this is a different program. This is called Astro Toaster. So it's the same. It's the same camera. It's the same telescope, but it's a different program that also does this live stacking. These are 10-second exposures at ISO 3200. For some sense of scale, the cluster is about 30 light years across. So that's what you're seeing in the image here. All right.
You can actually see one of the cool things I think about this, you can start to see kind of those colors in these stars. So something that we didn't pick up with our monochrome camera. Here with this one, we can kind of see some of that reddish glow to some of these stars as well. So to see that stars truly do have different colors. Okay, well, I'm gonna, now that you've surprised with what we're looking at, I'm gonna just go ahead and share my screen again to show you where we were looking, or where you're looking. So if we go back to our star map here, finding that W shape of Queen Cassiopeia, again, not too far away from Pegasus. Queen Cassiopeia is that W shape there. And while we use the middle star Navi, which is Ivan spelled backwards after Apollo 1 astronaut, we went down one arm of Queen Cassiopeia to find the double cluster in Perseus. Now, if we follow to one of the brighter stars in Cassiopeia at the end here, Calf, just off here, slightly towards the zenith, that's when we have Caroline's Rose cluster right there, almost straight overhead tonight. And because it's in Queen Cassiopeia, that star cluster that Tad was showing us is going to be visible all year long. And a kind of a more historical mark, Caroline Herschel, she is one of the few female astronomers from history that does get acknowledged every now and then. But most of the astronomers in history that are acknowledged are, of course, the male scientists. So it's always a good thing to recognize what our female and astronomers of other cultures as well have contributed, because a lot of what we know now couldn't have been known without their contributions. And so Caroline's Rose cluster there is a gorgeous view of one of the contributions that have been made over many, many, many years. Okay, one of the questions that came in, can we see Andromeda in the Twin Cities? Yes. Now, again, clear night, we're going to get to as many targets as we can upstairs with our telescopes, but it does take a little bit of time to move them across the sky. But let's take a look at where the Andromeda Galaxy is tonight. And again, we're going to go back to Queen Cassiopeia here.
And I guess not to spoil the fun too much, that is what we're trying to get in view.
Okay.
It'll take a few minutes. The telescope it's got to do about a 180. It was looking all the way over to the west, southwest, so it's got to go all the way back around. And as I'm sure you'll mention, it does take some longer exposures to capture something like this.
Yes, it does. But it is definitely worth doing. It just takes a little bit of time. So if we're looking here, Queen Cassiopeia, and we have Caroline Roses up towards the zenith here. If we just go back down just a little bit to kind of this portion of Queen Cassiopeia, this triangle here, and if we just go towards Pegasus, we'll actually run into the Andromeda Galaxy here, M31. Another way I like to find it, that I actually find it a little bit easier, is again going back to our fall square here in Pegasus and finding Andromeda, which you can imagine here's this main line of the Andromeda constellation here with these fairly bright stars. But then if you were to connect it from the head of Andromeda here that connects to Pegasus, and kind of imagine another V of stars coming up this way, M31 is just off to the side of those two central stars in that V of Princess Andromeda. So this part of the sky, again, as we get from fall into winter, is very, very rich in some of these great deep space objects. And so M31 is a fairly faint thing to see here in the cities. It is hard, but we can see it from our roof deck. We have our telescopes. But if you get not even necessarily that far out of the cities, out from the light pollution, you can actually see it with the naked eye. And this is the farthest object that the human eye can see without any instrumentation, without binoculars or a telescope. And the Andromeda Galaxy is about 2.5 million light years away. So when we're going to look at this here, when Tad's ready and he shares the screen with us when he's ready, we're not looking at the light from this galaxy that left the galaxy tonight. We're not looking at this galaxy as it was even yesterday. We're looking at this galaxy in the light that left it 2.5 million years ago. Now that's really mind-boggling because looking into space or looking through a telescope is also like looking back in time. So you might be scratching your head like, well, what is a light year? I thought it was measurement of time. And it turns out it's not. The name is a little misleading. A light year is a measurement of distance, like a meter or a foot or an inch. So it is the distance light can travel in 1 year. So another example would be like Sarah. Say, Sarah, run as far and as fast as you can for 1 minute. So whatever distance that happened to be, that distance that I would run all out for 1 whole minute, that would be called 1 Sarah minute, the distance I could run in 1 minute. So 1 light year is that time or that distance light takes to travel, that it can travel over 1 year. And so the light from Andromeda that we'll see here tonight left the galaxy 2.5 million years ago. So there is still a kind of a 1-to-1 correlation between the distance of a light year and the time it takes, because light does in space travel at the speed of light. There's nothing out in space to slow it down. So it can travel at its full speed. It doesn't have to put on the brakes or anything like as if it was going through air or going through water. Those are two mediums that can slow down the speed of light. But it is quite a large object. Here in the cities, when we look at it, it might look like a little tiny smudge in the sky, and it might not look like very much. But the galaxy is actually bigger than our own Milky Way in how much physical space it takes up. And it actually would be bigger than the full moon. That's how much space in our sky it occupies. But many of the stars in the outer regions of the galaxy are very faint, and they are hard to see. And so what we're going to look at here, as soon as the telescope gets over there, is going to be the core of the galaxy. So we'll see kind of the central core, and we'll see a few kind of bands or some of the arms of the Andromeda Galaxy here, because it is a spiral galaxy, much like our own Milky Way. You ready for us, Tad? Not yet? Okay. There was another question that came in. Are we using active cooling on our cameras for long exposures due to noise? Now, our cameras, one of them, our ZWO can get down to like -10 degrees Celsius, and it does have its own fan cooling inside of it. So when we get back to that camera and screen share, at the bottom of the screen, you can actually tell what temperature it's at. And so far, we haven't been turning it on because just outside, it's been hovering around a 1 degree Celsius, just on its own ambient temperatures out in our roof deck. But yes, if we were to turn on that cooler of the camera, that would definitely cool things down. And so that way, the heat that the equipment actually generates of itself would take out a little bit of that variability in the camera image. So our cameras can be cooled. I don't know if we turned it on tonight. Okay, another question that came in. Has the Bell had to engage with surrounding businesses or buildings to ensure our own night sky isn't impinging on our light pollution? We haven't. What we mainly focus on upstairs are some of those brighter objects, so it really hasn't been terrible for us. It really hasn't impeded what we're focusing on. Now, if we were really going to get into astrophotography, like the point where we want to start selling our images, things like that, we'd probably try to work something out. But right now, we're just having a lot of fun taking the pictures and just using our telescopes, because there really is nothing like seeing an object or seeing Saturn's rings or a globular cluster or a galaxy with your own eyes. And in this case, live stacking it through a telescope, that live feed through our telescope. And so if we really were going to get into image processing and things like that, we could probably start asking around. But we're in the cities here. There's only so much light pollution that we can avoid. If we really wanted to get it, we'd travel a little bit further out of the cities. But yeah.
Hey,
Okay,
Sarah,
so there's a question here. Go for it,
we
Ted.
had a problem with Sarah, we had a problem with the telescope. Kind of hit the telescope and the mount got very, very friendly with each other, which they're not supposed to do. So it's just going to be another minute here while we realign. I'm trying to get the other scope also going. Well, It'll be another few minutes. Sorry
Okay.
to sound like an airplane pilot here.
Can you share the screen of M45 from earlier this evening? I don't know if you are able to do it on the tablet.
It's not quickly. I can,
Okay.
but not quickly.
Okay. But there was a question here. It's a long one, so it's going to take me a little bit of time to read this. Okay, I think this sounds like it was a question from MIFA in their talk. So, Leanne, I was not here for MIFA's talk earlier this evening, so I'm not quite sure what your question is relating to. So I'm sorry about that. I'm not able to answer Clump of Velocity's question here. Okay. But let's go take a look back at our star map then. Like I said, over in the east, this is where we're having a lot of the winter kind of jewels. I think of them as, because they're my favorite things to see. The Pleiades, the double cluster, the Hyades, those are all open clusters in the sky. But this time of year, and as we get a little bit later in, maybe another few weeks, we're going to get the Orion constellation rising. And that is actually one of my favorite objects. And it's actually the object right behind me here. It is actually a star forming region. And so instead of these clumps of stars that are all together kind of bound, you think of them siblings, because they're all formed at roughly the same time, but they're all different. Some of them are larger, some of them are smaller. They're all formed in these clouds of gas and dust called nebulas. And so that's the picture behind me. It's actually my favorite thing to look at in the sky. And that's rising just off to the edge of our star map here in the belt, just hanging off the belt of Orion the Hunter. And then as we go around, we can see Capella here. Oh, it looks like Tad's found something for us.
All right. I hope this is coming into view. Working on getting this. This is M31. It's not I will say it's not a Hubble image. But we're going to try to get this in a little bit better view here. This is with our Canon T6 again. And Sarah, I'm going to let you talk about M31. Again, I know we've already touched on it briefly, but I'm sure we'll get some great questions about this very fantastic galaxy.
Okay, so now that we have a visual to go off of, yes. So M31 is the Andromeda Galaxy that we were just looking at on the star map not too long ago. So it's just off to the knee of the constellation of Andromeda, near the constellation of Pegasus. And while it looks like it's fairly small here in our camera image at the moment, we're just staring at the galactic center, that kind of bright, fuzzy, kind of almost a yellowish glow to it here on the bottom of the image. Now, the Andromeda Galaxy here is much like our own Milky Way in that they are spiral galaxies, meaning they have our center, they have the core, the kind of the nucleus of the galaxy, but then they have nice spiral arms that kind of spinning out in their identifiable structure. Because there's a few different categories of galaxies. Some of them that don't have this kind of defined nucleus with these arms going out of it. They're just kind of all held together. Some of them are kind of just blob shaped, and they're kind of oval blobs. We call those elliptical galaxies, which are much different than our own spiral galaxies that have these nice defined arms in them. Well, it turns out that these spiral arms of Andromeda and the spiral arms of the Milky Way galaxy, these two galaxies, our own and Andromeda, will actually collide in about 5 billion years. So while in general, things in outer space are moving apart from each other due to expansion and things like that, these two galaxies are actually going to merge. Now, when they do merge, it's not going to be a hard collision like two soccer balls hitting each other. Because most of the space that we're looking at here in the galaxy, this kind of just hazy glow of it, these stars are so far away that we can't pick out each of these individual stars here in this image of the Andromeda Galaxy. So the stars are, all that light's kind of blended together, and it's lighting up a little bit of that gas that's in between all the stars as well. And so when our galaxy and the Andromeda Galaxy merge, it's more like they're going to pass right through each other. And the stars are going to just pass right by each other, but then it's going to be mixed up, kind of like hitting blend in a blender without actually having any individual particles hit each other. And we know this happens because we can see past evidence of other galaxies doing that. Because as they merge, those spiral arms, or some of them are going to get flung out, and they'll create these big, huge tails and of stars just kind of streaming into space. It'll take a few million years for the collision to settle down. And million years is probably on the short time frame of things. But then once that does happen, our two galaxies will settle down into one even more massive galaxy. But we are the two largest ones currently in our local group, our local neighborhood of galaxies. So while Andromeda here doesn't look too big in this image, it actually expands quite a far way out into space. It's just very faint, and you would need to take some longer exposures to see the full extent of the galaxy here. Okay. Any questions so far? Now, the Andromeda Galaxy, I think it's easier to find than our own Milky Way galaxy is, because I can still see Andromeda from the Bell observation deck, especially through our telescopes. But I can see it as a little smudge in our sky every now and then under a slightly darker sky. I actually have a harder time finding our own Milky Way galaxy spread across the sky from west to east right now, or in the summertime, kind of that north to south spans. But I have some pretty good luck at finding Andromeda in our night sky. Okay. Well, let's take a look at our star map again as Tad is getting our next image up and running. We are nearing the end of our time together. So if there are any remaining questions, please make sure to put them in the Q&A box and we'll get to them. But we have looks like about maybe 5 minutes left here to try for one last object maybe. But a few things I'm going to encourage you to go out for, and Tad, if you're ready, interrupt me at any time. But a few things I'll encourage you guys to look out for this week, or next time we get a clear sky out, take a look. We definitely have Mars. We have our planets. Look for Pegasus, because that's going to be your guide to finding a lot of things in the sky. And you can star hop from Pegasus, finding the head and going to M15. You can find Pegasus and go off the other side back to Andromeda, find M31. Cassiopeia here again, that W in the sky is definitely something to learn about and learn to find, because that's again going to be another one of our signposts where you can star hop from one star to another across our sky. One question came in about Andromeda. Can we observe any of the spin from Andromeda Galaxy, or does it proceed at a rate of hundreds or millions of years? I'm not quite sure what the rotation rate of Andromeda is, but what we do to measure, or what we do as we're looking at the stars in our own galaxy to figure out the spin rate, is we look at the individual galaxies, or individual stars, because stars, they all orbit the center of the galaxies, but they don't move as a solid structure. Those arms of the galaxies actually are kind of like density waves, and a star over the course of its orbit around the entire galaxy will move into an arm and it will move out. So it'll move into a denser part and it'll keep moving out. So there's a larger structure that's not based on any one or two stars. So I'm not quite sure what an individual's star orbit is, or what that rate of rotation of Andromeda would be. But galaxies are really kind of, their motions are really fun to study and learn about there too. Okay, so it looks like we're looking at Andromeda here now through a slightly different view. This is through our other camera. For whoever asked about cooling, we have that briefly at the bottom of the screen. But you can kind of start to see our center glow of this galaxy, and then cutting across kind of diagonally across the screen here, this is kind of a darker dust lane. So we can start to see one of those spiral arms of the Andromeda Galaxy kind of cutting from the upper left down kind of a little bit towards the lower right at an angle here. You can also see some dust lanes coming in, not too close, but not too far from the center of the galaxy here, just a bit up to the upper left. We see some more dust lanes cutting across. We're starting to see some of that structure of the Andromeda Galaxy. And even in this camera, it does not do it justice of how expansive this galaxy truly is in our night sky. Okay, but this is a gorgeous picture, Tad. I'm glad you were able to get our camera up and pointing at that. This is a gorgeous image. Okay, he looks like he's deep in thought about something there. But a question came in: can we see the Pleiades from the Twin Cities? Absolutely. The Pleiades are my favorite objects to look at in the sky. They're just in Taurus, the bull, so they're rising just in the east right now. So it's a prime time to find them, and they'll be high in the sky all through winter. So you have until like early to mid-spring to see them and really enjoy them. And that is actually one of the objects that's probably best observed either with the naked eye or binoculars, because a lot of our telescopes get too far in of a field of view and it cuts off some of the stars. And so that is definitely a naked eye object or binocular object, I think. But they're really fun to look at. Have we got any Mars material back to Earth? That's a great question. And the answer is yes. There is a rock, I believe they've nicknamed it Black Beauty. It's a chunk of Mars that broke off who knows when and happened to come to Earth in the form of a meteor and hit the surface. Now we know it's from Mars because of the chemical composition of it is different from the chemical composition of rocks native to Earth. Now, one of the other things we're trying to do, and it was actually just released this past week, NASA got approval for it, is that the Perseverance mission that launched here from Earth in July, it will land on Mars in February. Part of that mission is to take rock samples and store them away for future return to Earth. And so what came out this week is that NASA, through its review, was deemed they have enough knowledge and know-how and planning to successfully get that return sample mission back through a partnership with the European Space Agency as well. So it's going to be a multi-mission mission. So the Perseverance rover is going to be the first stage of it. And then the European Space Agency is going to do the next stage where they're going to get something on the ground to go retrieve it from its location once Perseverance lands. And then we'll get it from the surface of Mars up to an orbiter. And then that orbiter is going to collect it. And then something's going to go from there back to Earth. So it's going to be a multi-staged mission with many different spacecraft. But yes, we have a piece of Mars here on Earth, and we are planning to get more on purpose. Okay. So let me check here. We are just about out of time. And so I'm going to return us back to our star map. And I have just a few quick wrap-up announcements to share with all of you. And so I do want to point out where the Pleiades are, M45. They're just off Taurus the Bull here, not too far away from Mars. You find Mars in the sky, just a little bit further east. The Pleiades, that's a nice, beautiful open cluster. Maybe we'll get to take a look at that later in the week because we are having telescope observing either live or a stand-in presentation if the clouds get in our way. But there are telescope images to be seen for the rest of the week as well. With that, I want to talk to you, just remind you what's happening tomorrow night. Tomorrow night, we're talking with Jessica Heim on cultural astronomy and the importance of starry night skies for people across time and place. And then we are also having another session of live telescope observing tomorrow night. Again, if the weather cooperates, it'll be live views, much like it was tonight. If the weather is cloudy, we will definitely have images through telescopes, and so you'll still kind of get that same experience. It just won't be active as if you're looking out your own window tomorrow night. It all depends on what the weather allows us to do. But thank you to all of you for participating in night 3 of our virtual statewide star party, and to all of our partners who have helped make this week a success and being here with us over the course of the evenings. So thank you, and a special thank you to Ruth and John Huss for their generous support and the Clean Water and Land Legacy Amendment for part of their funding as well for this week's events. So it is now 10 o'clock. Thank you so much for everybody for joining us on night 3. I'm glad the weather finally cooperated where we are able to get a few steps, few views up in our live night sky.
All right, Sarah, before we kick everyone off, I will say that the telescope and the camera are now supposed to be taking images of Messier 1. At least if I've got it in the right part of the sky. This is M1, also known as the Crab Nebula. And if anyone's still around, you might want to give a few brief words about M1. I'm not. It might be at the very center of this image here. Although
I
it
see a
is
few pixels there, but I'm going to save this for Saturday night because we have some fun stuff to talk about on Saturday night about stars and their life cycles.
Great teaser then. All right.
So I'm going to save that as a surprise, and hopefully people come back on Saturday, talk more about the life cycles of stars. Okay. Bye, everyone. Thank you so much for being here tonight.
Stay safe.
Stay warm.